Hello everyone, thank you for joining today's presentation. Today's presentation will focus on LAN-to-LAN VPN. We'll be covering VPN overview, how to set up LAN-to-LAN VPN using some protocols, some advanced VPN features and troubleshooting tips, and then we'll have a Q&A session at the end. What is a VPN and what is it used for? A VPN creates a private and secure connection over the internet to allow remote ends to access and share each other's resources. There are two main types of VPN connections: remote dial-in user VPN and LAN-to-LAN VPN. For this presentation, we'll be focusing on the LAN-to-LAN VPN connection. This type of VPN allows remote routers to connect to each other's LAN. It is useful for connecting multiple branch offices together so they can share resources. We'll go over the steps involved in establishing a VPN tunnel. The first step in creating a VPN tunnel is a dial-in step. To create a tunnel between two sites, one site will act as the dial-in or the VPN server, and the other site will be the dial-out or the VPN client. The dial-out site will initiate and send a connection request to the dial-in site. The second step is authentication. The routers will exchange authentication information, and if both match, they will then proceed to the next step. Then they will negotiate VPN parameters such as the remote networks they can access on each other, the encryption algorithm to use to secure the data, a keep alive mechanism to use, and so on. If they both agree, then the next step, the tunnel is established. After the tunnel is established, the routers will then start routing traffic to each other. We'll go over a visual presentation of how data is transmitted after a VPN tunnel is established. Here we have a data that is destined for a remote network that's on the internet. A user through their computer sends this data to their local router. The local router receives this data and then adds a VPN header to it. This process is called encapsulation, and then it sends the encapsulated data across the internet to the remote router. The remote router receives this data and strips the VPN header from it to reveal the data contained within it, and it then forwards this to the destination device. Continuing with the previous slide, some VPN protocols takes a step further by encrypting the data before encapsulation. So the contents of the data is protected as it goes over the internet. These are some industry standard VPN protocols which are supported on current DrayTek routers. These include GRE, PPTP, L2TP, IPsec, SSL, OpenVPN, and most recently WireGuard. Here we have a compatibility list showing the VPN protocols which are supported on current DrayTek routers. Today we'll be focusing on two popular and recommended protocols, which are IPsec and SSL VPN. IPsec is a secure VPN protocol, and it supports two modes, which is main mode and aggressive mode. Main mode is used for scenario when the dial-out router has a dynamic or static IP. An aggressive mode is used when the VPN client is behind NAT. In comparison, SSL doesn't require either side to have a static IP because DDNS can be used. Both protocols offer strong encryption. However, IPsec will perform much better than SSL because of our router's dedicated IPsec processor. IPsec is an industry standard protocol. Therefore, it will be compatible with many third-party vendors. However, SSL is strictly DrayTek proprietary, so it can only work between DrayTek routers. IPsec could become fairly complicated to set up, depending on the version and mode used. SSL, however, is always fairly easy to set up. So before you proceed to set up a LAN-to-LAN VPN, here are some useful information to check and note down. You want to check the type of internet connection that are on both sides and check that it will be suitable for a VPN connection. For example, if both routers are using 4G WAN connection, then it may not be possible to set up a direct connection between them. Also note if they've got a fixed IP or dynamic IP. This way, you can select a suitable protocol for the connection. Ensure that both routers support the same VPN protocol that you want to use, and that one can be set as dial-in and the other can be set as dial-out. Check that both sites are using different LAN network addresses so as not to create a routing conflict. You also want to check that the two routers support the same security protocols to ensure successful VPN negotiation between them. And lastly, keep a note of the settings that you will make on both sides to ensure clarity. We'll now focus on IPsec VPN. I will demonstrate how to set up VPN between two sites that have a static one IP address. Here we have a London site and a Liverpool site. The London site will be the dial-in site and the Liverpool site will be the dial-out site. This table outlines the information that will be applied to each router to set up the VPN connection between them. I'll refer to the information on the table as we proceed with the setup. Before configuring an IPsec tunnel, within the web interface of both routers, navigate to the VPN and remote access page, and then enable IPsec VPN service from there. You can click OK to apply the change. This will require a reboot, and the router will prompt you to do so. So you can go ahead and accept the prompt to reboot the router. To create a LAN-to-LAN VPN profile, go into VPN and remote access, then LAN-to-LAN page, and click on the free index to open a profile. We'll begin with the London router, which will be the dial-in router. To start, you open the profile and select Enable to enable the profile. The call direction should be set to dial-in. And the idle timeout is set that to 0 seconds so the tunnel does not go down when there's no traffic going through it. We select the IPsec tunnel protocol here. This router supports both IKV1 and 2. In the remote VPN gateway, we put in the one IP address of the other router. The pre-share key is entered, so both routers will use the same key. Here we can select or remove the security methods that we want to allow or not allow. Under the TCP IP network settings, we can put in the local LAN address of this router on the local network and the LAN network address of the remote router in the remote network box. After this, you can click OK to save the profile. We'll now move on to the Liverpool site, which will be the dial-up router. On that router, you open a LAN-to-LAN VPN profile and enable the profile. The call direction will be set to dial-out. Enable always on so the router can dial out automatically and keep the tunnel always on. IPsec tunnel is enabled. Here we're using IKEV2. Enter the one IP address of the dial-in router in this section. The pre-shared key is entered as well. Here we can set the phase 1 and phase 2 proposals in this section. For phase 1, we've set it to use AS256 Delphi-Hellman Group 21 and SHA-256. For phase 2, we've set to use AES-256 and SHA-256. In the IKE advanced settings, we can set the key lifetime, the phase 1 and 2 key lifetime. This is the default key lifetimes on the router, but if you're connecting to a third-party router that is using a different key lifetime, you can change it from here. Continue with the dial-out profile. We can set the TCP IP settings here. We set the local LAN network of this router on the local network, and the local LAN network of the remote router is set in the remote network box. We click OK to apply this change. After we've set up the VPN profiles on both routers, we can check if the tunnel is up from the VPN and remote access connection management page. Here we can see the tunnel information in green. It shows the profile name, the VPN protocol that we used, the remote router's WAN IP and the LAN network address, data rate, and the tunnel uptime. After the tunnel is up, we can see on the routing table the static route that the router has created for the remote network. After confirming the tunnel is up from the information that we can see on the connection management page and routing table, we can also check if it's passing traffic. We can use the ping tool on the router's diagnostics page to enter the LAN IP address of the remote router, and we can ping it to see if we get reply. As we can see on the image on the screen, the traffic is sent over VPN, and we do get replies. This confirms that routing is working, the tunnel is passing traffic. You can also ping other devices on the remote network and see if you get replies. We'll now move on to the next protocol on today's agenda, which is the SSL VPN protocol. Here we have two sites, again, a London site and a Liverpool site. The London site will be the dial-in site and the Liverpool site will be the dial-out site. So I will refer to the information on this table as we proceed with the setup. We'll begin with the dial-in router. Again, on that router, you open the LAN-to-LAN VPN profile and enable it. The call direction will be set as dial-in. We set the SSL tunnel to enable, and then you put in the WAN IP address of the remote router in this box. SSL uses username and password for authentication, so we enter that in this section. Under the TCP IP network settings, we put in the local address of this router and the local LAN address of the remote router. You can click OK to save the profile. The SSL VPN service port is set to 443 by default. Should you wish to change this, you can do this from the VPN Remote Access SSL General Setup page. And here you can specify the alternative port in the port setting. We'll now set up the dial-out router. Open the VPN profile on the dial-out router and enable it. You can set always on to enable, so the tunnel again doesn't go down when it's idle and the router will automatically dial out. Call direction should be set to dial out. And we enable the SSL VPN protocol. Here we enter the remote router's WAN IP address and its SSL port number. Put in the username and password that two routers will share. And under the TCP IP network settings, we can set the local LAN network address of this router and the remote LAN network address of the other router. And then we click OK to save the profile. After setting up the VPN profiles on both routers, we can check to see if it's up. On the screen here, we can see the tunnel information in green, and it shows the type, which is SSL tunnel. On the routing table, we can see two entries for the SSL tunnel that was created. The first entry shows the VPN, the remote router's LAN address, which can be reached by the VPN interface. The second entry shows the IP address, which the dial-in router has assigned the dial-out router. This IP is part of the dial-in router's local LAN network. We'll now focus on some advanced additional VPN features. These include VPN trunk mode, accessing multiple remote subnets through the same VPN tunnel, IPsec NAT translation for sites that share the same local subnets, DrayTek VPN matcher service, and how we can use Virgo ACS management platform to configure multiple VPN tunnels at once. VPN trunk allows us to set up VPN backup and failover. There are two trunk modes that we can set up. One is the backup mode. We can use this when the remote site has two WAN connections. So the backup tunnel will dial out to the remote router should the remote router's primary WAN connection fails. The second mode is load balance mode. Here we create two tunnels going to the same remote network using two WAN interfaces, and the VPN traffic will be load balanced across both tunnels. This gives an additional benefit of increased throughput because the bandwidth of the two WAN connections are combined. The next advanced feature is network settings for more subnets. LAN-to-LAN VPN profile can also be configured to access more remote networks on the remote site. Supposedly, there is already a VPN tunnel established between two sites. To access a second LAN on the remote router, we only need to add the network address in the VPN profile. So in the image on the screen, the HQ router has two LAN subnets. So to access the second LAN subnet, we need to add the network address for the second LAN on the branch router. To do this, we go into the branch router's VPN profile and click on the More Remote Subnet option and enter the additional network address and subnet mask. With this setting, we'll be able to access the 192.168.1.0/24 and 192.168.5.0/24 networks that are on the HQ router. In a standard LAN-to-LAN topology, the local network at each site must be unique. The primary reason for this is to avoid creating a routing conflict, as if both sites have the same LAN subnet, it will not be possible for the router to determine whether the traffic is destined for its local interface or the VPN interface. Here we have two routers with the same IP subnets. We can choose a new network address for each router. For router A, we've chosen the 192.168.100.0/24, and for router B, we've chosen 192.168.200.0/24. It can be any network address of your choice. To make the change, we go into the VPN profile on router A, and we can select the option to enable translate local network. We're translating LAN 1, so you can select the LAN subnet that you want to translate from the drop-down box, and then we enter the translated IP address. So you need to make the users on both sides aware so that they need to use the translated network address when trying to access device on the remote network. So we need to do the same on router B and apply the settings and save profiles. VPN Matcher is a free cloud-based solution within DrayTek routers that allows for creation of VPN tunnel between sites that do not have a public WAN IP address, be as a result of the router being behind NAT or it's using a 4G internet connection. Such routers can be set up to connect to the VPN Matcher cloud server, and the cloud server will then act as an agent to allow the routers to exchange the network information required to establish VPN connection. With the ACS SD-WAN VPN feature, it's not possible to automatically set up VPN between multiple routers with just a few clicks. Using the SD-WAN VPN wizard, we can create two types of LAN-to-LAN VPN, which are hub and spoke and full mesh. We'll go over these two modes in the next slides. With the hub and spoke, one hub device will be selected to be dialed in by multiple spoke devices. We can use this to create VPN between HQ sites and branch offices. In the setup page, set the type to full mesh, and then we select a device that will act as the hub device. ACS will automatically populate all the rest of the devices within that ACS network in the spoke devices. You have the option to remove devices from this box should you wish. Select the protocol that you want to use to create the VPN between the routers, and then you can save this setting and ACS will automatically build the VPN tunnels between them. With full mesh, tunnel is created between each device in a mesh topology, so they're all connected to each other. To create VPN within multiple branches, you go in the VPN setup page and set the type to full mesh. All the devices within the network will be populated under the full mesh devices. Set the tunnel type to IPsec. Here we're using IPsec, but you can select any protocol that you wish to use. Okay, so we'll move on to troubleshooting. The most common VPN problems are as a result of misconfiguration. Before configuring a tunnel, we recommend outlining a table of all the common settings for the tunnel, like what is showing on the screen right now. We'll go over some of the common VPN issues you may face and give some tips on how you can resolve them in the next slides. After you set up VPN profile and the tunnel does not come up or appear in the connection management page as we saw on earlier slide, here are some things you can check to try and resolve the issue. Okay, so you want to check that the VPN service is enabled. On current routers, this wouldn't be an issue because before you set up the LAN-to-LAN profile, the router will prompt you to go and enable the VPN service if it's not already enabled. If you're using older models, you may need to go in and check this. If you're using IPsec, then it's good to check that the pre-shared key is entered correctly. I suggest putting this down in a text editor, copying it from there into the router so you're sure there's no typo when you're entering it on the router. On the dial-in router, check that you've specified or entered the correct WAN IP address for the remote router. The LAN subnets are set on the TCP IP settings on both routers' VPN profile has to match. Otherwise, they won't be able to negotiate the VPN parameters successfully, and the tunnel will not build. If you're using SSL or any other VPN protocol that requires a username and password, it's best to check the password has been entered correctly. So I'd just enter it again on both routers to be sure that it matches. So you want to set the call direction on both sides accordingly. So one side has to be dial in and another side has to be dial out. So they can't both be set to the same call direction. Otherwise, the VPN tunnel will not establish. Another problem we have is unstable VPN connection. So here the tunnel comes up, but it goes down very frequently, which means that you can't always access resources at the remote site. So here are things you can check to resolve this. So ping to keep alive should be disabled on the dial-out route router if you're having this problem. DrayTek routers will have other types of keep alive mechanisms. So it's not recommended to have this option enabled if you're having disconnection issues. On the dial-in router, the idle timeout check that is set to 0 seconds so that the tunnel does not drop when there's no traffic going through it. So you want to check that the IKE key lifetimes on both routers are exactly the same. So if one router is using a much longer key lifetime compared to the other router, then they will not be able to renew the security association the same time, and this would cause the tunnel to go down. So you want to check that this is set the same on both routers. Another cause of unstable connection is WAN disconnections. So you can check on the router's online status physical connection page, check the WAN uptime to see if it has recently changed. Another issue, VPN common issue, is unable to pass traffic. In this case, the tunnel is up, but you can't access devices on the remote network. So the first thing to check is to check the routing table on both routers. Make sure that they have the correct entry for the remote networks of the other router. If this entry is in there, then you can proceed to do a ping test from the router's ping diagnostics page. So you can try to ping the IP address of the remote router and see if you get replies. If you do get a reply, then it's probably likely there's something on the remote device that is not allowing to send traffic back to you. That could be a Windows firewall or some kind of firewall antivirus software on it. So you could try turning this off and see if you do get replies from it. So here's a recap of the topics we've discussed during this presentation. This includes the VPN overview, LAN-to-LAN VPN. We've talked about DrayTek VPN specification, IPsec and SSL VPN protocols, some of the advanced VPN features, and we've gone over some troubleshooting tips. So also on the screen are useful links which you can refer to for VPN setup and troubleshooting. This concludes the technical presentation. We will now finish up with a Q&A session to answer any questions that you may have.
Thank you, Doris. That was a very insightful overview. As you can see, there's a lot of information to take in. Let's see what questions have come in. I will now pass you to Lucas and Boris to cover some of today's questions.
Hello, guys. We received a lot of questions. Thank you very much. We're gonna cover some of them because there is a time limit, obviously, here. So the first question is about the call direction. Why are there both dial-in and dial-out settings for IPsec VPN when they both connect to the same endpoint and require the same settings? So can you explain what the call direction is and when setting up LAN-to-LAN VPN, how to set it up? And do we need to have this set to both for the traffic to flow into both directions?
Okay, so so we talked about in the slide, the first stage of setting up a VPN is dialing. So one site has to be the VPN server, which is listening for incoming connection requests, and the other site is the client, which initiates the connection request. So yes, one site has to be the server, so it's their listening, and the other site has to be dial out. Now, you may see in the profile, there's an option to set the call direction to both. So that means that router can be both a VPN server, it can be listening, and it can also dial out. So the point is to have at least have one of the routers acting as a server. It can be both or it can be one, but one of them has to assume the role of server or client so that they can establish the tunnel, if that makes sense. Now, after the tunnel is created, it doesn't matter which side is dialing out or in. The tunnel will flow either way. So yeah, after the tunnel is built, the call direction doesn't really matter. The call direction only matters for the VPN establishment, if that makes sense.
Thank you for that. My second question I've got here on the list is basically about the articles and examples we may provide to people. And we actually do have a lot. As far as I am aware, we have answers to most of your questions, guys, there. But Doris may have the knowledge of where to find it as well on a daily basis. So the question
yes.
is the VPN setup guide page where we can find some illustrated VPN configuration examples.
Oh yes, we've got plenty of examples, setup examples, which you can find on our website. So if you go to draytek.co.uk and go to under the support menu, support articles, there you can search for the relevant documents, and it should bring up a list of some articles that may you can refer to help you set up a VPN.
Another question we've got is about the teleworker remote dialing user, which wasn't really the subject of this webinar. Can we block the number of remote users connecting via VPN to our network? So I believe somebody would like to have like a single computer connected remotely rather than a whole network. So like a VPN that can or has a secure account. So it's also about the security here.
Okay, so for the remote dialing users on the VPN protocol, we didn't cover this, but on the VPN profile, you have the option to specify the dialing users internet address on the profile. So the router will only allow that client who is coming from that IP to connect to it. You also have the option to only allow a single computer or a single device to use that profile to connect to the router at any time using that profile.
Okay, thank you very much.
And also we've got sorry, to add to that, we also have the option two-factor authentication, if that helps, for additional security. So when
that's right.
a device is connecting, they can go through two-factor authentication before they're allowed to connect to the router. So that's an extra security there. So
yes, on security part, yes, many new DrayTek routers do support that feature now. If your router doesn't have it, maybe you need to upgrade the firmware. And obviously, the VPN is on its own is another layer of security. So if you use a secured version of or secure a VPN protocol that people consider to be secure enough these days, then that's probably the best option for you to access your data. There's yet another question, if you don't mind, Doris, about the VPN behind NAT. I have a setup where a DrayTek router is going behind another NAT router for its WAN connection and needs to dial out to create a VPN tunnel to a device with a static IP. So will that work? So I believe there's a LAN-to-LAN setup here. Consider.
Yes, that will absolutely work. So if you don't need to use I believe you're referring to the VPN matcher service. So if one site has a public IP address and the other site doesn't, you can create a VPN connection between them directly. So yeah, that would absolutely work. As long as one site has their public address, the VPN client or the dial-out router can connect to it. It doesn't need the dial-out router doesn't need to have a static or even a public address.
There's just one more question I noticed that was quite common, and it's about the VPN mesh hub and spoke options. What are the pros and cons of the full mesh hub and spoke connection? What the differences are? Can you just briefly cover that, please?
Okay, so with the full mesh option, all the routers are connected to each other. So whereas the hub, all the routers are connected directly to the hub. So the con, if the hub router was to go down, then that means the other sites can't talk to each other. Whereas in full mesh, if one goes down, the other sites can still talk to each other because they're connected to each other, if that makes sense.
Okay. We actually covered that just now, but I think it would be nice to visualize the VPN behind NAT again. It's so common. So there's yet another question where we see many mobile broadband connections these days, where the mobile providers are using RFC 1918 addresses like 10.000, etc. How do you establish a VPN LAN-to-LAN connection when the remote WAN has for example, 10.0.0.0.1 IP address?
Okay, so if you've got a router hasn't got a public address or has a private address like the 10.0.0 address, if both routers are using this sort of address, then it's where we use the VPN matcher service to link them together. Yeah, so this is service on current DrayTek routers. All you have to do is register the routers to the cloud server, and it would help them exchange information that will help them establish the tunnel. So yeah, the VPN matcher service can be used in scenarios like this where you've got routers that haven't got public addresses behind that. You can create a tunnel between them. And this is a free service that is included on DrayTek current models.
Okay, thank you very much. Okay, do we have time for more questions, Shane?
You can do one more.
Okay. Let me find something that wasn't answered yet, maybe more challenging. SSL VPN. Do we need to have a valid self-signed certificate to configure such a tunnel?
Yes, you need to have a valid SSL certificate on the server. So a certificate that's not expired. So if that's what you mean. It can be self-signed or third-party signed, but it needs to be valid for the VPN negotiation to
So yes.
work. Yes, so you need a valid certificate.
Definitely you need to guys a certificate that is signed by certificate authority when we set up dial-in user accounts. So each software they're gonna use will be happy with that certificate. For LAN-to-LAN, DrayTek routers can actually negotiate with the valid certificates that are signed by the routers, really. But that was the case. We'll see with new firmwares how we're gonna have that running. But that should work fine as well. Let me see if we have more questions. Okay, which VPN type is the fastest and which is the most secure?
I would say IPsec. IPsec is the fastest and it is secure as well. So if you're in terms of performance, if performance is your top priority, then go for IPsec.
Good. Well, thank you once again, Doris and Lucas. Before we close the session, let's just take a look at what's coming up in the month of September. Thank you. So due to the success of our last Q&A webinar in Q3, we'll now be hosting this event each quarter. The Q&A webinar is an open forum to discuss anything DrayTek related. So please register your interest when the invites hit your inbox. That will be happening on the 21st of September. So this now brings us to a close of today's LAN-to-LAN webinar, and I would like to give a big shout out to our presenter Doris for delivering today's presentation and answering your questions, and not forgetting Lucas for assisting with the Q&A delivery. If you have any further questions, then please don't hesitate to send them to info@draytek.co.uk for one of our dedicated support teams to answer. For those questions that we have not been able to answer today, we will get back to you within the next few days. And finally, if you have missed any of today's content or wish to review this webinar at a later date, it will be made available to view within the next 48 hours on the draytek.co.uk website. Sadly, this now brings us to the end of today's session, and I would like to thank everyone who has joined. I hope you found today's content informative and you managed to get the answers to your LAN-to-LAN questions. If not, then please keep an eye on your inbox. Therefore, to close today's webinar, we at DrayTek want to wish you all an enjoyable day. So thank you for joining.